this video, we are diving into machine learning with a hands-on tutorial on how to implement a multi-layer perceptron or MLP with backpropagation for multi-class classification using Python. We will be working with the class iris dataset. Let's get started. First up, let's import the necessary libraries we are using. Popular libraries like Pandas for data manipulation, split learning for building the MLP model, and some additional tools for pre-processing and evaluation. Here's the code snippet. We start by importing pandas, pre-processing and train test bit from the sklearn, along with tools for standardizing the data, defining our neural network, and evaluating the results. Next, let's load the iris dataset, which contains measurement for three different types of iris flowers: setosa, vesicolor, and virginica. We load the dataset from UCI machine learning repository and assign columns name for clarity. Now we need to pre-process the data. We separate the features and target labels, encode the labels as numeric values, and split the dataset into training and testing sets. We use label encoder to convert the class labels into numeric values. Then we split the dataset with 80% of training and 20% of testing. Next, we standardize the feature values to have a mean of 0 and unit variance. This is important for improving the performance of our MLP. We fit the scalar to training data and use it to transform both the training and test set. Time to build our perceptron model. We will create a network with three hidden layers, each containing 10 neurons, and train it up to 1000 iterations. The MLPC classifier class from sklearn allows us to define the number of hidden layers and the number of neurons in each layer. Here we have set three hidden layers, each with 10 neurons, and increase the minimum number of iterations to 1000 to ensure convergence. Once the model is trained, we can make predictions on the test set and then decode these predictions back to the original class labels. The predicted labels are then transformed back to their original class names for better readability. Finally, let's evaluate our model performance using a confusion matrix and classification report. The confusion matrix shows the number of correct and incorrect predictions for each class, while the classification report provides matrices like precision, recall, and F1 score for each category. And there you have it. We have successfully implemented an MLP with backpropagation to classify iris flowers based on their features. With just few lines of code, you can create a powerful neural network model capable of handling multi-class classification tasks. If you found this tutorial helpful,